Hello everyone, and today we're going to be talking about the primary flight controls. So let's just go ahead and jump in. So hopefully we remember how a plane can move. We have three axes: vertical, lateral, and longitudinal. So the lateral axis is the motion it extends from one wingtip to the other wingtip. Motion about the lateral axis is called pitch, and it is controlled by the elevators. The longitudinal axis extends from the nose to the tail of the plane. Movement about this axis is called roll, and it's controlled by the ailerons. The vertical axis of motion extends from the top of the airplane through the bottom of the airplane. The motion about the vertical axis is called yaw, and it is controlled by the rudder. So like we said before, the three primary control surfaces on an airplane are the elevator, ailerons, and rudder. So the elevator causes the airplane to pitch up and down and is deflected by moving the control stick or yoke forward and backward. The elevator is attached to the horizontal stabilizer. The ailerons are used to roll the airplane. They are deflected in opposite directions to each other by moving control stick yoke left or right. Ailerons are attached to the trailing edges of the wings. The rudder causes the airplane to yaw from left to right and is controlled by a set of pedals in the cockpit. The rudder is attached to the vertical stabilizer. And we all are a little bit familiar with this from practicing on the simulator. So hopefully we still remember that, because it's been a while since we've got to do that. And so movement of any one of these surfaces, or a combination of, changes the attitude of the airplane by deflecting the air in one direction or another and creating different pressures around the control surface, thereby affecting the lift and drag caused by the airfoil or control surface combination. This causes the plane to pitch, roll, or yaw. So at slow air speeds with less relative wind, the flight controls may feel less effective than at high air speeds with greater relative wind. At higher air speeds, the flight controls become more responsive and feel more firm. So as you recall, we can move the elevator by pushing or pulling the yoke or the stick. We've been practicing with yokes. So when a pilot pulls on the yoke, the elevator is deflected upward. This upward deflection of the elevator creates a tail down force which pushes the tail of the airplane down, pivoting the nose of the airplane up and causing it to climb. Same principle applies to descents. So applying forward pressure on the yoke deflects the elevator downward, pushing the tail up and forcing the nose down. And again, this up-down motion is what we refer to as pitch. An airplane may use any of several elevator types and locations based on the airplane's mission and its preferences of its designers. A T-tail is a configuration features a vertical stabilizer with the horizontal stabilizer mounted on top. Thus, the tail has the shape of the letter T. This configuration provides consistent control surface movement throughout the phases of flight because the elevator is above the effects of downwash from the propeller, as well as airflow around the fuselage and wings. In some airplanes, such as seaplanes, T-tails are necessary to keep the elevator as far from the water as possible. However, T-tails are disadvantageous in terms of stall recovery. They can go into a deep stall from which it is difficult to recover. This is because in very high angles of attack, the turbulent airflow from the wings impinges on the elevators, making it difficult to obtain smooth airflow over the tail and elevator needed for recovery. A stabilator is a single-piece control surface that combines the functions of the horizontal stabilizer and elevator into one movable surface, hence the name stabilator. Stabilizer and elevator put together. So a stabilator can be considered one-piece horizontal stabilizer that pivots from a central hinge point, making it very sensitive to control inputs and aerodynamic loads. The widespread Piper Cherokee, which I believe a couple of you practiced on, is an example of one that uses a stabilator. So canards are similar to conventional elevators that utilize two lifting surfaces. The difference is that canards are mounted on either side of the nose of the airplane as opposed to the tail. Theoretically, canard configurations are more efficient and lift the nose of the airplane, resulting in less drag for a given amount of lift. This is particularly true for high-speed and long-endurance flights. On the other hand, a canard-fitted airplane is less dynamically stable than conventional airplanes. When a conventional airplane is flying straight and level and encounters a sudden disturbance, the downforce provided by the horizontal stabilizer quickly gets the airplane back into the original flight attitude. So elevons are surfaces combine the functions of elevator and aileron. These designs are usually found in military airplanes such as the F-17A. Elevons can be moved differently based on the needs of the pilot. If they are moved together, then they result in a pitching movement, and in contrast, a differential movement of the same surface gives the pilot roll authority over the airplane. Alright, so ailerons are located on the outboard trailing edge on the wings of an airplane. When a pilot turns the yoke left or right, the aileron on the side deflects upward while the opposite aileron deflects downward. For instance, if the yoke is turned left, the aileron goes up while the right aileron goes down. The left aileron goes up while the right aileron goes down, and the airplane rolls left. The ailerons work by changing the effective shape of the airfoil of the outer portion of the wing. Changing the angle of deflection at the rear of an airfoil will change the amount of lift generated by the airfoil. With greater downward deflection, the camber of the airfoil is increased, thereby increasing lift. Alright, so the different types of ailerons. All of these crazy words. So, flapperons. As the name applies, these are a combination of flaps and ailerons in one surface. Using a device installed in the control system, a pilot can deflect the surfaces in opposite directions like ailerons or together like flaps. For this design to stay effective, the surfaces must be mounted a distance away from the actual wing in order to prevent airflow disturbances at high angles of attack and low airspeed configurations. We will talk more about flaps in the next lesson for secondary flight controls. So, spoilerons, that's right, spoilerons, are a combination of spoilers and ailerons into one surface. Spoilerons help direct an airplane's turn by decreasing the lift produced by one wing, but they do not necessarily increase the lift of the other wing. This causes the airplane to roll in the direction of less lift. Alright, so the rudder. The rudder is located on the back of the vertical stabilizer. The pilot moves the rudder using a pair of pedals in the cockpit. When a pilot pushes on one pedal, the rudder is deflected in that direction. For instance, if the pilot pushes the left pedal forward, the rudder is deflected to the left. When the pilot depresses the rudder pedal, deflecting the rudder in the direction of the pressed pedal, the deflection of the rudder creates what is in effect a vertical wing that produces a horizontal force. This horizontal force will point the nose in the direction that is desired. Remember, we call it yaw. Alright, so hopefully you remember in the last lesson on rotorcraft, lift, and stability, rotorcrafts also have flight controls, but they're very different than the fixed-wing airplanes. Rotorcraft typically have main rotor blades that rotate over the fuselage, providing lift, pitch, and roll control. They also have a smaller rotor located on the tail used to counteract torque, the yaw of the aircraft. And we talked about the collective. The collective is a control located to the left of the pilot's seat and is operated by the pilot's left hand. When the collective is raised, there is a simultaneous and equal increase in the pitch angle of all main rotor blades. When the collective is lowered, they all decrease equally. So the cyclic is a control that's used to manipulate the swash plate in a way that will alter the pitch of an individual rotor blade. Cyclic maneuvers tilt the arc of the main rotor, which in turn tilts the lift vector and allows the pilot to control the aircraft in pitch and roll. Alright, so this is kind of common sense. Depending on the type of plane, you're going to have different control systems. So the simplest would be cables and pulleys to control everything. Then there's the hydraulic. and obviously the fly-by-wire, so we'd have computer control systems. So adverse yaw is the phenomenon associated with turning an airplane. It is the natural and undesirable tendency for an aircraft to yaw in the opposite direction of a roll. So whenever the pilot moves the control yoke left or right in an airplane, the aileron corresponding to the direction of movement deflects upward, while the opposite aileron deflects downward. So for instance, moving the control yoke left moves the left aileron up and the right aileron down. The upward deflection of the lift aileron reduces the lift produced by the left wing. The opposite happens with the right aileron. The downward deflection increases camber and increases lift on the right wing. The airplane rolls into a left turn. However, the increased lift on the right wing also increases the drag on the wing, slowing down that wing in relation to the opposite wing. This causes the nose of the airplane to yaw toward the wing with the increased lift and drag. So the nose initially moves the opposite direction of the intended turn. This is termed adverse yaw. So adverse yaw is counteracted by using the rudder. So by adding some rudder input, you can offset that. Alright, so coordinated turn is one in which the relative wind is aligned with the aircraft's fuselage. If the wind is coming from one side or the other, then the airplane would be in either a slip or a skid. In a slipping turn, the rate of turn is too slow for the angle of bank. The nose is pointing too much to the outside of the turn. In a skidding turn, the rate of turn is too great for the angle of bank, and the nose is pointing too much to the inside of the turn. So another way to think of coordinated flight is flight in which the movement of the airplane is such that the tail tracks the nose. To coordinate the turn, rudder is applied to the yaw. So the airplane is neither slipping nor skidding. A pilot monitors this by watching the turn coordinator, which contains the inclinometer. A simple way to see if a turn is coordinated is with a yaw string, which is a piece of yarn taped to the nose of the airplane on the center line. When the string is pointed straight toward the tail of the airplane is in coordinated flight. Yaw strings are often seen on gliders as well. Alright, so the turn coordinator is an instrument used in the cockpit to tell the pilot the quality of the turn. A ball contained in a curved glass tube, called the inclinometer, shows when a turn is coordinated or in a slip or skid. So when the ball is in the same direction as the turn, the airplane is said to be in a slip. And then the opposite, it'd be skidding. So a pilot can correct slip or skid using rudder input while turning the airplane using the ailerons. The pilot deflects the rudder pedal corresponding to the deflection of the ball. So if the ball is on the left side of the tube, the pilot deflects the left rudder and vice versa. So this is called stepping on the ball. Let's see a quick video of this.
If the ball is to the right, push the right rudder. If it's to the left, push the left rudder. This will move the ball back toward the center. Your goal is to maintain whatever rudder pressure is needed so that the ball remains caged between the two vertical lines. Think of the cage, the center section of the inclinometer is the airplane's nose, and the ball is the airplane's tail. When the ball is centered, the tail is tracking the nose, and your airplane is happily experiencing coordinated flight.
Alright, so your assignments will be listed below this. If you guys have any questions, feel free to shoot me a message. Hope you have a good day.